A very good evening to one and all present over here. Myself, Dr. Sheena. Am I audible to everyone? Am I audible? Okay. Thank you, Kartika. Thank you, Aparna. So we'll start the session. As you all know, we have actually completed the dental anatomy and dental histology over the last few weeks, and we had discussions, we had tests on that. So we are going into the next very important topic of dental materials. Especially, we will be discussing three main chapter that is required in this session. That is the physical properties, the impression materials, as well as the gypsum products will be actually dealt in this session. So, first of all, 1 minute. Oh, I'm very sorry for the technical error. Am I is the PPT seen now? Hope it is been visible, right? Okay. Okay. So let us start the topic. First of all, I would like to discuss some important topics on the physical properties of dental materials. So first of all, talking about all these, especially the initial topics is so much easy. So I'll be just stressing on the important points that is required for or the frequently asked question has been discussed. So you know what is stress? Stress is always defined as a force per unit area. Means you can see in that image, a person is pulling a body, I mean pushing a body. So what happens is like there is an internal resistance that is built up inside that body. That is called as actually the stress. So always you have to note it is the internal resistance. Sometimes the question might be like internal resistance, external resistance. So never get confused. It is always the internal resistance of the body because of the external forces. So it is always actually expressed in force per unit area. And you have to know the unit. Unit is like pounds per square inch or megapascal. So these are the questions being asked, like the internal resistance first question, force per unit area second question, and third the unit, that is pounds per square inch, or also called as the megapascal. So this is one question. As I told earlier, what is stress? Stress is actually defined as the internal force that is opposing on a applied load. It is never an external force. Never think like that. So you need to know what is complex stresses. Complex stress is actually a combination of three important stress, which you all know. That is actually the tensile stress, compressive stress, as well as actually the shear stress. So this three important stress together, it is actually called as the complex stresses. Now, what is tensile strength? Stress. As you can see in that image, two forces that are directed from each other in a same direction. So what happens is like it causes tensile strength. A stress always cause the elongation of a body. So always keep that in mind. Compressive stress means something has been compressed, or shortening of the body take place when compressive stress is given. In tensile stress, a body tend to stretch or elongate. Compressive stress, as you can see in this image, two forces are acting from either side. So what happens is like there is shortening or compression of the body taking place. Now, what is shear stress? there is two sets of force which is directed parallel to each other but not in a straight line. That is very important. Till now we have actually seen they are seen in a same straight line. Here it is not seen in same straight line. That is a very important point. Another question is like the second point. Shear stress always tend to resist the sliding of one portion of a body over other. So it is resisting the sliding of a body when compared to the other, right? And it also, because since it is acting in two different direction, what happens is like there is twisting or torsional action of the body or the material taking place. So these are the important topic or important things that you have to keep in mind. So as I told, there is stress. Now the types of stresses, three important stresses coming. And shear stress, important point, it is not in a straight line and it causes the twisting or the torsional action of a material, and there it actually resists the sliding of the body. Now, what is strain? As you all know, whenever we give a push to a body, there is some change that is taking place in that body. That deformation of length to the original length is called as strain. So please keep that in mind. So we have discussed stress and strain. So what is strain? Strain is defined as an applied force or load, a deformity. Yeah, we know that is a deformity that is occurring, that is called as actually the strain. Now, another important property is Poisson's ratio. What is Poisson's ratio? So, when as I told, when there are complex stresses always acting on a body, complex stress we have already discussed earlier, that include the like torsional stress, the compression. When a lot of stresses act on a body, there are two strains that is generated. As you can see in the image, there is lateral strain, a strain on either side, and longitudinal strain, a strain. Also called as the axial strain that is actually happening. So the ratio of the lateral strain to longitudinal strain or lateral strain to axial strain. Longitudinal strain is also called as axial strain. So please keep this in mind. That is a very important point. Poisson's ratio is actually a division or like a ratio between the lateral strain to the axial strain, also called as a longitudinal strain. Please keep in mind. The two important point that you have to keep in mind. Sometimes the question might be, what is the ideal or for an ideal isotropic material, what is the ratio? It is actually 0.5. So please keep this in mind. 0.5 is the ratio at which, like normally the ideal isotropic material have a Poisson's ratio. Now, sometimes the question might be, what will be the range of a normal material? So for a normal material, it will be less than between like 0.3 to 0.5. So this is very important point that you have to keep in mind. Okay. So we have discussed about stress. We have discussed about strain. We have discussed about actually the Poisson's ratio. So always keep in mind, it is the lateral strain divided by the longitudinal strain. Longitudinal strain is also called as axial strain. Please keep these points in mind. Next, coming to the very important topic, that is stress strain graph or stress strain curve. So please keep this in mind. Here you can see on one axis it is strain, on lower axis it is actually the the stress and strain, right? So you can see there are four important points that is given with red color. See, proportional limit, yield strength, ultimate strength, fracture. Keep this in mind. 4 points is given: proportional limit, yield strength, ultimate strength, and fracture. So what you have to keep in mind is like the two important points, that is the yield strength and the proportional strength, comes under elastic region. That is very important. Please keep that in mind. So, and other two, ultimate strength and fracture, come under plastic region. Hope you understood. So we have two regions. EP, you can memorize like E to P. Elastic to plastic. Elastic 2 comes proportional limit and yield strength, and ultimate strength and fracture comes under plastic. Hope you understood. So important thing that you have to keep in mind is like, when a material is an elastic limit, it can come back to its normal position. I stretched a rubber band, it came to its normal position when I left. That is elastic region. When I stretched a material from A to B, it cannot come back to its normal position. That is plastic region. Hope you understood that, right? So here you have to actually know what is proportional limit. always think proportional limit is stress that is directly proportional to strain. You can see the point A. A means till that point, the stress will be directly proportional to that of actually strain. If we actually give pressure to a material, it will come back to its normal position. That is actually called as the proportional limit. See, as stress is increased, strain will also get increased. When strain is doubled, the stress is also doubled. So that is actually the interlinking in proportional limit. So sometimes the question will be like, in which area the proportional limit comes? So as I told, E, first comes E, then come plastic. So inside the elastic region, the proportional limit comes. Hope you understood. So next is modulus of elasticity. You have to very importantly keep this in mind. Modulus of elasticity is also called as elastic modulus or Young's modulus. Very important. These three important terms you have to keep in mind. Modulus of elasticity, elastic modulus and Young's modulus. So I have made a code or a mnemonics for this. See, same, SAME. ME is actually the modulus of elasticity. So something that come with S, that is the answer for modulus of elasticity. S, see the red thing which I have actually noted, slope. S for stiffness. So for same elastic modulus, ME means modulus of elasticity. Two important terms normally comes in question. The stiffness of a material, it is actually the stiffness of a material or the slope of the elastic region. You can see in this image, there is a slope that is called as the modulus of elasticity. That is specifically given slope of elastic region. As I have told earlier, there is two regions, elastic and plastic. The slope of the elastic region is called as the modulus of elasticity. Hope you understood. First is proportional limit. Proportional limit comes under elastic region. Next, we are talking about the modulus of elasticity, also called as elastic modulus, also called as Young's modulus. You have to keep the mnemonics SAME. ME is the modulus of elasticity. S means something coming with S. I have given slope as well as the stiffness of a material is calculated as modulus of elasticity. So what do you mean by this? See, a stiff material will have high modulus of elasticity. That is very important point that you have to keep in mind. Okay, see, when stiffness, when the modulus of elasticity is very high, the stiffness is high. Means restrictive material should have high modulus of elasticity. Means it should be stiff enough to resist the masticatory force that is acting on the surface. Hope you understood. Modulus of elasticity is equal to stiffness of a material. Understood. Modulus of elasticity increased, stiffness increased. Modulus elasticity decreased, flexibility of the material. Hope you understood this. So next two important thing that you have to keep in mind, usually asked question. If it is a steep slope, the slope is very big. That means modulus of elasticity is big, stiffness of a material is there. If it is a very shallow slope, means it is not flexible, it is a very flexible material and it have a low modulus of elasticity. Hope you understood these topics. So you have to memorize the mnemonics, SAME. Modulus of elasticity means stiffness of a material or the slope of the elastic region in a stress strain graph. Understood? So hope you understood this important point. Steeper the slope means more the modulus of elasticity means more the material stiff. Understood? So the question, the stiffness of a dental alloy is determined by. So you all know what is the answer for this. What? It is actually the modulus of elasticity, as we have already discussed from the mnemonics. Now, next important topic is resilience. I have again made a mnemonics for this. See, RE. S. You just take the three important terms from RES. R is resilience, E is the energy, S is the springiness. So these three important terms you have to keep in mind when you study about resilience. R is resilience, E is the expression. So resilience is always the express of energy. So that is the amount of energy that is absorbed by a structure when it is stressed not to exceed its proportional limit. Hope you understood. So it is also called as springiness. So whenever you see springiness of a material or springiness of a material, you have to give the answer resistance. So as we have seen in the early question, whenever we see stiffness of a material, go for modulus of elasticity. Whenever we see springiness of a material, go for resilience. You have to keep these three important mnemonics. RES, resilience means E for express of energy and S for springiness of a material. So the question, the greatest stress which can be produced in a material where the stress is directly proportional to strain. So hope you all know, as I have told, stretch should be directly proportional means it should be within the elastic limit. We have already studied two important terms in elastic limit, which are, one is what? Proportional limit and modulus of elasticity. Modulus of elasticity, we already studied, is something like it is like the it is not the proportional limit. So whenever stress is directly proportional to strain comes, the answer is proportional limit. Hope you understood. Next is elastic limit. So elastic limit, sometimes it has been actually told as elastic limit as well as proportional limit is almost the same. See this image. As I told earlier, this too comes inside the elastic limit. That is, elastic limit is the time beyond which the material moves into a plastic form. That's it. Okay. Next important term is yield strength. What is yield strength? You can see here. Yield strength is defined as the strength, you can see in this about it is defined as stress at which a material exhibits a limiting deviation from the proportionality. As I told, till you can see the proportional limit. This too comes under the elastic region, but proportional limit means stress is directly proportional to strain. There is no change. When it comes to yield strength, there is slight discrepancy. Even if we pull the rubber band, it comes back to its normal position in proportional limit. If we pull the rubber band, even though it comes back to its normal position, there is very small deformity seen. Understood? Even though it is seen in the elastic region, that is called as yield strength. That is why they are saying there is a very small percentage of 0.2 percentage permanent deformation that is sealed in yield strength. Hope you understood. Very important section, elastic region, plastic region. Inside elastic region, we have studied three important things: proportional limit, yield strength, modulus of elasticity is actually the slope. Don't forget that. Okay. And yield strength means even though stress is directly proportional to strain, but there is very small deviation, that is of 0.2 percentage of permanent deviation or deformation that is seen. Next important area is toughness. What is toughness? Toughness is the entire energy that is required to fracture a material, or it is a total. That is why I have written as TO. TO toughness means the total area under the stress strain graph. Very important. So whatever area come under the stress strain graph, that is actually the toughness. So brittleness, you know, it is actually the inability of a material to sustain plastic deformity because it will break before it reaches a limit, it actually break. That is called as brittleness of actually a material. Next question. The material behave in certain way above and below the proportional limit on a stress strain graph. Which of the following is correct? Please read. You people read that. Above the proportional limit, the material function as plastic, whereas below the proportional limit, it behaves as elastic. So what do you think? Of course, that is the answer. We have already discussed. Initially, it starts with what? Elastic. Elastic moves into plastic. E, then after alphabet comes P. Think like that. So the answer is option A. Above the proportional limit P, it is actually the plastic area. Below that, it is elastic area. So this is again asked question, what is ductility? Ductility is always the property of a material to withstand permanent deformation under tensile load without rupture. Keep that in mind. That is a term where what we give here is actually the tensile load. What is malleability? Malleability is actually the ability of actually a material to withstand permanent deformation under a compressive load without rupture. So that two terms you have to keep. Sometimes the question might be, so you might get confused, right? Ductility and malleability, we have studied some other definition, like it is the property of a material to be drawn into wires and all, right? But the question being asked is like this: under tensile stress or under tensile load or under compressive load. So never get confused. Ductility under tensile load, malleability under compressive load. Next, very important MCQ question: which is the more ductile and malleable pure metal? Gold. Gold is the most ductile and malleable pure metal. Then comes the silver. See, platinum ranks third in ductility and copper ranks third in malleability. So that is also a very important question. So in the platinum, so we always are used to gold, silver, and platinum. Platinum come a third in ductility. Okay, why? Copper comes third in malleability. Please keep these important points in your mind. Now, what is hardness? So, always the question is like, it is that term will be there to resist the scratching, right? It is actually the property of a material to resist the scratching of a material that is called as hardness. So again, very important topic. Usually asked question: what is like anatomy, or what is the size of the indenters that is used in the hardness testers, etc. So commonly used question. So what are the types of hardness? First is Brinell test is there, Rockwell's test, Vickers test, and Knoop test. So what do you mean by Brinell test? So these are actually the type of hardness that is present. So I have added only important MCQ question being asked. Brinell test, they have been asked where it is commonly been used. It is used for determining the hardness of metal and metallic substances. One. Second important point is like they consist of a very small ball, steel ball. You can see in this image, this is actually the Brinell testing machine, and they consist of a very small ball. Now, what is the diameter of that? That is 1.6 mm diameter. Important question. So it is used for metal and metallic materials. What is it made up of? It is like a small round ball with a diameter of 1.6 mm. See the next important box that is being seen. Brinell test is one of the oldest tests. So, which is the oldest test? Brinell test. And it is used for determining the hardness of a material and is directly related to the proportional limit. That is very important because sometimes the question might be like, among the below, which is correct for the Brinell test? So, that is a very important point that you have to keep in mind. It is related to both the proportional limit and the tensile strength, ultimate tensile strength. So, please keep that in mind. Next, see, it is used for the dental gold alloy also. So you got the important points like what is the shape of that, what is the diameter of that, where it is used for metal, metallic as well as dental gold alloy. Next is Rockwell test. So think it is we got a rock of a diamond shaped rock. Mm. So Rockwell test is actually having a like ball of a conical diamond point. You can see in this image, it is having a conical diamond point and it is not suitable for brittle material. These are the important points that you have to keep in mind. Next is Vickers test. Again, ask question. The test use what type of indenter? You can see in this image, it is actually a square-shaped pyramidal indenter. That is important point that you have to keep in mind. Okay. And it is used for casting gold. Right. First, we have actually studied for metallic casting gold. Here also, it is actually used for casting gold. Next is Knoop's test. Knoop's test, you can see the image. Again, here it is having a pyramidal shape diamond indenters. Oh, you have to study various shape of each indenters. That is very important. And important question is area is like they are used for testing thin plastic. We have told like early cases we cannot use brittle material. But here, nope. We can use for very thin plastic or metal sheet or brittle material where the force applied does not exceed 35 Newton. Very important. Nope. Think that no, there is no. It doesn't give no to anything. It can be used for actually testing most of the material which has been rejected by other testers. Keep that in mind. That's it. So no testing machine is actually used for all, like the brittle material, like the very thin plastic, like the metal sheet, where the force does not exist more than 35 Newton. Please keep that in mind. And you have to know the shape. Okay. That is, it is having a pyramidal shape. Hope you understood this, all these things. Brinell's test, what is the, where it is used, what is the shape? Rockwell's test, again, what is the shape? Brittle materials, it is not used, very much given. And we came to an area where no test, it say no to all, it don't say no to any of the material. So it is used in all the materials where the force does not exceed more than 35 Newton. Another important point, So, what is actually the commonly used test for measuring the hardness of plastics and rubbers? It is Shore and Barkle's test that is actually commonly used for measuring the hardness of rubbers and plastics. So, please keep this point in mind. Another important. So, as I told earlier, you have to always keep a notebook. It is not like in the in last day we'll be reading the entire topic. We'll be making just the points. You write the Brinell test. It uses a small ball of 0 point this much, this much. All the important points make a very important. That is called as flashcards. Keep preparing flashcards that will be very useful for you. Right. So, question. Please think. You think. Ability of an orthodontic wire to spring back to its original shape is related to. Where we studied that term, spring or springiness. Can anybody answer in the chat box? As I told, I'll give a gift for those people who actually answer. We have already discussed earlier, I have given a mnemonics, how you have to, where you have seen the springiness. Can anyone answer? Where we have actually given this springiness. Just now we have actually answered. Anyone? I'm in the chat box actually. I got answers actually. It is Resilience by Sangeeta Hajra. Very good. I'm very happy that you are actually hearing. Yes, very good. Resilience. As I told, the code is RES. Right. Very nice. So as I told, the name itself contained the answer RES. That is S for actually in the springiness. Super. Super. So next important term you have to know is ultimate tensile strength. What do you mean by you have to know the term? That's it. What is ultimate tensile strength? It is actually a stress before rupture. Just keep that in mind, nothing else. Ultimate tensile stress means before a material fracture, the stress is actually called as the ultimate tensile strength. Next important topic that you have to keep in mind is wetting. Just wetting, where an adherent get adhere to a particular surface. That is actually called as wetting. There is a lot of angle that is formed that is called as a contact angle. The angle that is formed between the liquid and the adherent surface. That is called as contact angle. So you have to know a very important point that I've added in this PPT. See, if the angle is 0 means complete spreading of, there is no angle formed, there is complete spreading of the material to the surface taking place. See, if it is actually less than 90 degree means there is good wetting, right? It is equal to 90 means there is some angle formed, there is no proper wetting taken place. If it is more 90%, more than 90, more than 180 means non-wetting. They form a ball. Means as the angle increases, they comes together so that the wetting doesn't take place. 0, think like that. Base 0 means good wetting. Whenever we also like we come to the 0, we'll have a good what nature, right? Like that itself. Wetting it starts with 0. 0 means it have a complete wetting or complete spreading of the material taking place. As it increases, good wetting, then it moves into non-wetting. Hope you understood. More than 180 means no wetting. It forms a ball. There will be less wetting being seen. How much should be the degree of contact angle for proper wetting? Hope you all know that answer. We know 0. 0 the angle means super wetting taking place. Next question for you all. The ability of an alloy to withstand mechanical stress without permanent deformation is reflected by what? See, fatigue resistance, hardness, elastic limit or elastic strain, resilience. So, of course, it is elastic limit and elastic strain. So, within that, the material won't actually move to a permanent deformation. I have already told that. Elastic limit, there is no deformation. As it moves to plastic, there is deformation taking place. Keep that in mind. Elastic to plastic, right? Another important term, linear coefficient of thermal expansion. Simply think, okay, you just see the enamel is having 11.4. എന്താണ് അതിന്റെ meaning? 11.4 the enamel will actually show a small rise of the material. ചൂട് കൂടുമ്പോൾ when there is increase in the temperature, there will be expansion of material taking place. But what do you think? We place an like what? A material, a restorative material on tooth. Do you think both the linear coefficient of thermal expansion of both materials should be same? അല്ലേ നമ്മൾ വെക്കുന്ന ടൂത്തിന്റെ പുറത്ത് വെക്കുന്ന മെറ്റീരിയലിന്റെയും toothum, the linear expansion should be same. അല്ലേ? Like what happens when we give heat? Think that the amalgam is having, see, it is 25. It will completely expand. But enamel will expand slightly. So what happens? The amalgam will give pressure on the tooth surface. There is chance of fracture of the teeth taking place. That is why we study the properties of dental materials. എന്തിനാ നമ്മൾ ഈ linear expansion ഒക്കെ പഠിക്കുന്നേ? That is why we select materials that is having the linear expansion similar to enamel. Then only there will be no cracks, damages, micro leakages, etc. Understood? See, enamel, so you have to keep in mind some of the numbers in this box. Enamel, it is 11.4. Super. Amalgam, it is 25. See the chart. Which do you think is near to enamel? GIC, silicate cement. Dentine, you see 8.3, it is almost near to the silicate cement. Understood? So always keep in mind the material that is very much near to our tooth is like GIC, silicate cement. Then you can see composite. Amalgam is somewhere far actually. That is why it causes most of the cases like micro leakages, corrosion, and there is cracking of the tooth taking place there because there is discrepancy in the linear coefficient of thermal expansion. So always keep in mind, this you have to keep in mind, enamel and dentine. Enamel have 11.4 and dentine have 8.3, that you have to keep in mind. Okay. See the question? Coefficient of thermal expansion of which of the following is most similar to that of the tooth? So we know that enamel is like we have already studied, it is 11.4, dentine is 8.3. So in most of the case they are asking like which is near to our enamel. So it is silicate cement. Always keep in mind the first cement that is near to our tooth is silicate. Second comes GIC. Okay, please keep that in mind. Next question, next area is creep. You all know what is creep. So it is actually time-dependent plastic deformation. That term is very important, time-dependent plastic deformation. There are two types, static creep and dynamic creep. Means a creep that actually occurs when there is a constant load, that is static. When there is actually a fluctuating load, a fluctuating stress, means first we apply 10 Newton, then we apply 20 Newton. So there is some deformation taking place. That is dynamic. When I gave 10 Newton, 10 Newton, 10 Newton, there is slight deformation taking place. That is static. Hope you understood. Question. Which of the following property of dental material is time dependent? Very easy. Creep. Next important term that you have to keep in mind. What is latent heat of vaporization? The name itself suggests. Latent heat of vaporization is also called as latent heat of evaporation. So what do you mean by that? When a liquid converted to gas, vapor, it is becoming. So what is the amount of heat required? That is required to convert vapor. The answer is entirely latent heat of vaporization. Heat required to convert a liquid to gas. So simple. So question, amount of heat that is required to change the boiling water into vapor. Of course, you know that is latent heat of vaporization. Next question is latent heat of fusion. So what do you mean by latent heat of fusion? It is the amount of energy released. So fusion means there is freezing of a liquid taking place. There is fusion of the liquid. Liquid was actually flowing as such. Now they are actually joining together. That is called as the freezing of the material that is actually taking place, right? So that is called as the latent heat of fusion. So always keep in mind when 1 gram of water, when we keep in fridge, it freezes, 80 calories of heat is released. Keep that in mind. There is some release of energy taking place. So 80 cal of heat is released. These are very important points that you have to keep in mind. So what is sublimation? You know, liquid going into a vapor state. Again, solid sublimation you have to memorize. SUB, S for solid. A solid moving into a vapor state, that is actually called as the latent heat of sublimation. Please keep this in mind. I think I have actually completed very important topics and very much asked questions, or I have actually gone through a lot of questions, and I have actually very much made a flashcards. This is actually a kind of flashcards which I have actually discussed in physical property. Next, we are actually moving into impression material. Okay, so you go through this and you actually try to solve, as I told, 100 to 200 questions you have to actually solve in each day, right? So next we are going into impression materials. So again, I have made some important flashcards in this. What is solution? That we know. We drink a water, that is solution. Water is, when we see water, what it is very homogeneous. So there is actually homogeneous mixture of a component in which the particle size is less than 1 nanometer. Very important, keep that in mind. Solution, homogeneous. Suspension means what? Think we actually have a juice with apple in that. Hmm? Think of a Faluda. Faluda have a solution and on that there is a lot of mixture being present. That is suspension. It is heterogeneous and which consists of actually solids that is spread in a liquid. Think about Faluda. That's it. Now, what is colloid? Colloid is actually a term between solution and suspension. That is in between solution and suspension. Their important point that you have to keep in mind is it's a fourth state of nature. Colloid is the fourth. So suspension, solution you understood, water vapor. Suspension is what? Faluda. It is a mixture of solid and which is heterogeneous. In between there is colloid. That is a fourth state of matter. So colloid is actually intermediate between the solution and suspension. Very important. And they have actually a particle size of that is very important. They have a particle size of 2 to 1000 nanometer. So that are also, so as I told, solution is less than 1 nanometer. Suspension is 1000 nanometer. That is why the colloid come under 1 and 1000 nanometer. Hope you understood. Now, what is soul? Soul is solid mixed in liquid. What is gel? Liquid mixed in solid. That is very important terms. Now, what is hydrocolloid? The name itself, it is a colloid. You know what is colloid. Colloid is actually a thing between the suspension and solution. When water is also there, that is called as hydrocolloid. When one of the component is water, it is called as hydrocolloid. Hope you understood. Solution, suspension, in between that there is colloid. One type of colloid is called as hydrocolloid when there consists of actually water in that. And the hydrocolloid is of two types, sol and gel. So you know that agar and all, it exists in two stages. That is sol and we'll be discussing actually. Okay. See, very important image. Solution we explained it is homogeneous. Particle size, it is like 1 nanometer. What about suspension? See the last picture, more than 1000 nanometer. In between that comes what? Colloid. It is actually a fourth state, 1 nanometer to 1000 nanometer. What is the fourth state of matter? Everybody know. Which is the fourth state of matter it is? We have already discussed. It is actually colloid. Very good. Sol gel transformation is seen in. This I have actually not taken. So I am simply asking like sol gel transformation is seen in which we have already discussed hydrocolloids. Colloids, hydrocolloids, as I said, colloid is a type, hydrocolloid is a type of colloid. They have two things, sol and gel. Hydrocolloid, sol and gel. So simple. Okay. That is why we always say agar, alginate are hydrocolloids. Agar and alginate, they move from sol to gel, gel to sol. Hope you understood. Now, some important confusing area. So again, make a flashcard of this. See, one side, chemical reaction, temperature. On upper side, rigid, elastic. Hope you understood. So set by chemical reaction means what? It will be setting by chemical reaction. It will be irreversible. That is very important. Whatever chemical reaction take place, it is actually irreversible in nature. While which are like temperature change taking place, when we actually change the temperature, it can come back to its normal position. That is called as reversible. So talking about rigid, it is of two type. I have made a code RIPE. RI means rigid, P for plaster and E for eugenol. Make a flashcard of that. Okay. So the rigid contain like the impression plaster and zinc oxide ripe. You can memorize it ripe. And temperature change, you know, rigid, you know, that is compound wax used to actually mix like this, right? It can come back, it is actually rigid type compound. Wax is also rigid type. So talking about elastic, alginate hydrocolloid is irreversible. We know about alginate, it is irreversible, right? But what in the case of agar is only the reversible type of hydrocolloid. Others, everything is what? Chemical setting and elastic type. So please keep this chart in mind whenever you answer. This thing, the chart and answer. Okay. So alginators, we already told alginate and agar are hydrocolloids in nature. Inelastic impression material are. So think about that chart. What is inelastic? That is not elastic. It is actually the impression compound. I told it is actually rigid type. Alginate, agar and polyether, everything actually came on the other side. See, elastic side and inelastic side. That is the rigid side. Please keep this chart in mind. Once you are like pakka with this chart, you'll be able to answer. Don't worry. Okay. Which of the following impression material is rigid? So rigid first, it comes under the first thing. Zinc oxide, eugenol, reversible hydrocolloids, alginate and polysulfide. So which is the answer? We know it is zinc oxide, eugenol. Okay. So impression techniques is of three types: mucocompressive, mucostatic and selective pressure. Just to know, these theories have been used for impression techniques. So mucocompressive means what? So the theory states that it actually records the tissue in its functional form. Just keep that in mind. Mucostatic means it is actually the undisturbed form of the mucosa is in actually the static form, or the undisturbed form, that you have to keep in mind. And what you have to keep in mind is the materials that is used. In mucocompressive, will be compressing that in the occlusal function form. So that is impression compound. See, you used to remember when we take the prosto impression, the patient is asked to do some functions. That is why it is called as impression compounds come under mucocompressive. Wax and liners also come under compressive. Static means once we place the alginate cement, we ask the patient to do functions? No. So a thing like that. Okay. So compressive means the compound, impression compound. Mucostatic means no movement, like our alginate, our zinc oxide eugenol paste, which we use, the impression plasters, etc. You can memorize like ape. Ape is alginate, P for plaster or Paris, E for zinc oxide eugenol. Very important. Keep this mnemonics again, make a flashcard and keep that in your mind. AP is like alginate, P for plaster and E for the eugenol. So the question comes, the most mucostatic, static you understood, we will be just placing, there will be no function of the jaw or the functional movement taking place. Thin mix of plaster of Paris, zinc oxide eugenol, free-flowing wax, reversible hydrocolloids, which it is actually, we have already said APE, app we studied where the plaster comes. So it is the thin mix of plaster of Paris. Okay. Most mucostatic among the following is zinc oxide eugenol. That is a very important question. We have already discussed it as mucostatic. So most mucostatic is actually the zinc oxide eugenol. Please keep that in mind. So coming to some important like topics we have explained from that box we have done. Impression compound. So we know what is impression compound. So I want you to actually see that box once more. See, impression compound. You can see the lower box. Compound means it sets under temperature, right? When we actually give water, we put in water, it becomes soft. When the temperature cools, they comes back to its normal this thing. It is rigid, but it changes in temperature. So that is what you have to keep in mind actually. So a very important AD specification 3 and impression compound, you have seen, you can see the image. Normally we use for the edengelism. I need not explain all those things. So there are two type, impression compound and tray compound. We have used to make the tray, and impression also we used to. Yeah, must have done in prosto and all, right. Important thing that you have to know here is the composition. See, the code I have made is rows come to school by colorful car. Please keep this in mind. Rows, I told, make a flashcard, note it down. Rows come to school by colorful card. R for rosin, 30 parts. Come, C for copal resin and carnauba wax. Always keep that in mind. Since it is actually a compound, it consists of wax and resin also, right? Next comes actually to school. T for talc. Talc is actually there. And S is like stearic acid, shellac, which are the plasticizers. Okay. And C, colorful car, it contain the coloring agents. Hope you understood. Please keep that code. Rose come to school by colorful car. Rosin, R. C for copal resin and carnauba wax. T for talc. S for the shellac and stearic acid. Colorful agents, coloring agents. Okay, hope you understood. So, rosin, copal resin comes in 30 parts. Carnauba wax comes under 10 parts. And important thing that you have to again ask question is like, which is the plasticizer that is used in impression compound? So you have to take that. Rows come to school. Schools, shellac and stearic acid is actually the plasticizer which is used. Hope you understood. This is very important question again. What is the glass transition temperature and fusion temperature? So there is some temperature at which we know the compound is very hard. When we get it as a plate, it actually loses its hardness. It is 39 degrees centigrade. So we always in Celsius we put in water, right? When it reaches 39 degree C, it actually start to form softened. That is actually called as the glass transition temperature. Now, what is fusion temperature? It is actually temperature at which the material softens into a plastic mass. It starts at 39 degrees Celsius and it completely becomes soft as 43.5 degrees Celsius. Again, make this a flashcard. Glass transition temperature and fusion. Fusion means we can actually fuse that, we can actually make that soft material, we can manipulate it. Hope you understood. So, important thing, ADA specification number, two things, impression compound, tray compound, composition. This code, keep that in mind. And important question, which is the plasticide use. All the S are plasticide, shellac, stearic acid, etc. Plasticide means it will have that improved properties also. Two important term, glass transition temperature, fusion temperature. Glass transition temperature is like 39 degrees. It starts to become soft. And one, it is very flexible at 43.5 degrees Celsius. Hope you understood. Next, very important thing is zinc oxide eugenol. Some important things that you have to keep in mind. Zinc oxide eugenol is of two types. The first one is hard. The second one is soft. Keep in mind. Type 1 is hard. Type 2 is soft. We know it is, you have already seen all these things as you can see in the image. It consists of a base paste, catalyst paste. Base is like white. Base is always white in color. Catalyst paste is actually red in color. Understood? And here you have to actually study the base contains zinc oxide, that is 87% maximum. And there comes some oils that makes that shiny surface and also it have that viscosity. Accelerator paste, base paste as I told it is white. Accelerator paste is red. That contain eugenol. That contains some accelerators like rosin. It contains some filler particles, lanolin, balsam, which actually increase the flow. And again, ask question is like, what is the product that is found once the base and like the catalyst get mixed? It is zinc eugenolate. Very important thing. Water is required for initiating this reaction, and water is also byproduct in this reaction. Keep that two important point in your mind. Okay, this two is very important. Water is required for the reaction. Water is actually made a byproduct in this reaction. Another important question. We are using zinc oxide eugenol. So which conditions accelerates its setting rate? It sets very fast. Which all condition? If the temperature is very hot, humid, high temperature, like our Kerala climate, it sets very fast. If there is zinc acetate, AC, accelerate, thing like that. Zinc acetate, it accelerate. Zinc acetate, high temperature, high humidity environment. This all increases setting. That is why we always know cool slab technique, we always say make the slab on which it is mixed, make it cooled so that the temperature, humidity, etc. decreases. We'll have enough time for actually making and mixing the material. Okay. Question. All of the following can be used to slow down the setting of zinc oxide eugenol except. So which are the method we have already discussed, which all accelerate? A. Accelerate zinc acetate, a hot climate and humid climate, and which decreases. See, adding a small, why I added this question is like to make you understand which are the methods to slow down the things. One, we have already studied what cooling the slab. Cooling the slab, slow down. Adding a small amount of glycerin slowdowns. Okay, so the answer is like adding small amount of water. What do you think? When we add water, it sets very fast. That is very important. It sets very fast. So the what we have studied, zinc acetate, humid climate, temperature increase, and adding amount of water increase the setting time. Which all slow down? Cool glass technique, adding small amount of glycerin. Okay, these are the techniques how we can actually slow down the setting of zinc oxide eugenol. Next question we have already discussed, which is zinc type 1 and type 2. Type 1 is what? Hard. Type 2 is what? Soft. So type 1 and type 2 zinc oxide impression paste differ with respect to. What do you think? Eugenol content, water content, its hardness after setting, their use. Very easy. We have already said it is hardness, right? Hardness and soft we have already discussed. Type 1 and type 2. Important point. Type 1, I told that is hard. Hard set occurs in 10 minutes and the type 2 occurs in 15 minutes. That is the difference between type 1 and type 2. Please keep that in mind. Next question. Zinc setting time of zinc oxide is best controlled by. It is cooling the glass slab. That is why when in our practicals also we used to say that always try to make the glass slab cool so that there will be enough setting time. Hope you understood the both difference. How to increase the setting time, how to decrease. Increasing is zinc acetate, accelerate. Humid climate, temperature, more the temperature. Here, adding glycerin, one. Second is like cool glass slab. What is the advantage of zinc oxide eugenol? Very important. Dimensional stability is actually the important term that you have to keep in mind. Lanolin is added in zinc oxide paste too. It increases the. These are some of the important points just that keep in mind. We have already discussed the impression compounds, all the property. Lanolin is actually asked like twice or thrice. It is increasing the flow of the material. So we are going into the next hydrocolloids. So what are the hydrocolloids? You know, there are two hydrocolloids, right? Agar, alginate. Best material for duplicating cast. What do you think? Which is the best material for duplicating a cast? It is agar agar. Always keep in mind, even though we use alginate in our clinical practice, best material for duplicating a cast is agar agar. The basic constituent of reversible hydrocolloid. Do you think, we know there are two type of hydrocolloid, agar, alginate. So which is reversible? Alginate, can we make it into to its normal position? No. Once alginate is set, it is not reversible. So it is agar. Again, coming to answer, agar is the answer. Okay. So as I told earlier, you have to always have a smart study. Smart study means here what I'm doing is actually wrong. The basic constant of reversible hydrocolloid impression is simply I'm saying agar because I'm not having time. You have to think about alginate. So you have to make a note like alginate is actually irreversible hydrocolloid. What is alginic acid? So I'll discuss on the further slides what is alginic acid. So that is how you have to actually study. We have to see why the other points are not there or not the answer for the particular question. Okay. So coming to agar. You know two important things. Agar is hydrocolloid, agar is reversible hydrocolloid, right? So we know agar, we know it has been actually taken from seaweed. Important term that you have to memorize here is, it is the sulfuric ester of a linear polymer of galactose. That is sometimes being asked, what is agar? So it's some sulfuric esters of actually galactose. Once it is set, it is having brush heap appearance. These are some of the flash points that you have to keep in mind. Okay, brush heap appearance. We know that is used for actually duplicating the cast as well as taking the impression material, right? So reversible means sol to gel, gel to sol. That is how it moves. It can move in both the way. That is actually given in that chart. Sol to gel, gel to sol. Okay, important point that you have, just this important points you have to know in agar. Agar, we know it is like we have eaten jellies, right? Agar is like a jelly thing. So do you think with this jelly we can take impression? No. This jelly which we get have to be made to some salt form. Right? It is called as liquefaction temperature, where the gel is converted into slightly viscous, slightly liquid state. That is called as liquefaction temperature. So what we do, take this jelly, put it in a container, he will heat it to 60 to 70 degrees so it flows. Then we will actually flow this agar to a impression material and we will take impression. Hope you understood this much. We'll get it as gel, we'll heat it in 60 to 70 degrees Celsius. At that temperature, they become sol. Once it is placed in mouth, what happened? Our saliva gives a cooling temperature, so it starts to set again. So at 30 to 40 degrees Celsius, they actually get converted, which is the mouth temperature, get actually converted to the gel form. Hope you understood, the jelly form. Then we can actually take out. Hope you understood. So what is hysteresis? So you have seen there is two phase C. One is liquefaction temperature, that is the gel is converted into liquid. Then we take impression. In mouth, it sets again. That is actually what? The gelation period. So this two phase, there is a time period, a temperature lag. That is called as a hysteresis. Hope you understood this. Very easy, right? Gel, we heat it in a container. in 60 to 70 degree, called as what? Liquefaction temperature. And we pour it in a impression tray. We'll take the impression in the mouth. It have a temperature of 30 to 40, that is called as gelation temperature. It sets. There is a temperature lag in between this phase, that is called as hysteresis. Next, very important composition, that is very important. See, we know agar consists of course, agar, right? So what agar also consists of? Borate. See, agar is the basic component. I'll make it very easy for you. Agar is the basic component, you know. And AB, think as AB. Borate is there. What happens is like borate actually increases the strength of gel. Okay, that is a property of borate. They increase the strength of the gel. What this agar and borate do is like we take the impression. To that we have to pour the gypsum, right? They prevent the setting of gypsum. See, we need to pour a gypsum product, like otherwise setting won't they prevent the setting. To compensate that, to the powder we add the potassium sulfate. See, it counter retard the borate. Hope you understood. So it have agar, it have borate. Agar and borate, what they do? They prevent the setting of gypsum which we actually pour. So prevent that, we have added potassium sulfate. Hope you understood this much. Then we know the filler particles like wax, alkaline benzoate is a preservative, and the water is also seen as a dispersion medium. That is the story you have to know. Agar and borate is there. These two things actually prevent the setting of plaster of Paris. So prevent that, we actually added what? Potassium sulfate. So simple. So what is synergesis? That is whenever what happens is like these materials, when we place in water and when we remove from water, they have some capacity to absorb and release water. That's it. So synergesis means loss of water is called as synergesis. Imbibition means they actually absorb the water. And two techniques are like laminate techniques means you need to know the term. What after injecting this syringe agar, we inject the agar and into a tray containing the alginate and we'll take an impression. That is called as laminate method. Hope you understood. Which material undergo hysteresis? So you know it is reversible hydrocolloids undergo hysteresis. Brush heap structure is formed in where? We have already studied. It is actually seen in agar. K2SO4 in agar is for? I've made a story. Agar borate to prevent this to actually prevent the setting of plaster of Paris. To accelerate the setting of plaster of Paris, we have added potassium sulfate. Hope you understood that story. Gelation temperature of agar is, we have studied two temperature, liquefaction temperature, gelation. We'll heat at 60 to 70 degree. We place in mouth. So in between the 30 to 40. So this is like 37 to 50, almost that degree gelation temperature. The technique of combining reversible, irreversible hydrocolloid is known as, I told now, what is it? It is laminating onto alginate. On center, we'll place agar, we'll take impression, that is laminate technique. Which of the following increases strength and decreases viscosity of agar hydrocolloid? I've already told, borax. Perforated impression tray are used in, we know, alginate, perforated, we are using that, so we know perforated impression tray. A dentist can best control the setting time of alginate. So I am going to discuss this. That is why I have actually added this. Now, talking about alginate. Alginate, again, they move from sol to gel. And do you think it moves in either direction? No, it is irreversible. Once it moves from gel to sol, I mean sol to gel, it sets. That's it. So that is why it is called an irreversible hydrocolloid. Again, they are of two types: fast setting, normal setting. Important, alginic acid. I have already discussed in some other question. See, again, alginate is also taken from some seaweeds. It is again a story. Keep in mind. It is called as alginic acid. What is the problem with alginic acid? We know we need to mix alginate with water. Alginic acid does not have the property to mix with water. So what we do is like we added some salt to the alginic acid. That is the first one, sodium potassium alginate. Hope you understood. From nature we get it as alginic acid, but alginic acid is of no use. So we embedded some sodium and potassium to that. That formed sodium potassium alginate. Hope you understood. Pakka, right? Now, inside that, they have calcium sulfate. We add calcium sulfate. Now, this calcium sulfate and the sodium potassium alginate mix to form calcium alginate gel. You can see in here, calcium alginate gel. That is the reaction normally taking place. Hope you understood. Simple. Alginic acid is which we get from nature. It is insoluble. So make it soluble, we added some salt to that. That salt, we added calcium sulfate. They two reacted to form calcium alginate gel. So what happens is like this two fast, if we place them together, there is fast reaction taking place. To prevent their love, actually it is love taking place between calcium sulfate and sodium alginate. To prevent that, we added sodium phosphate. They are retarders. They prevent the calcium sulfate. So study like a story. We get alginic acid from nature. It is insoluble. So what we did, we added some salt, that is calcium, potassium and sodium salt. And to that we added calcium sulfate. They react together. So they always reacted fast to form calcium alginate gel. To prevent that, we actually added the sodium phosphate. Remaining you can study. Diatomaceous earth is always used as a filler. Always the potassium titanium fluoride act as actually the hardness. So this is another important question. How it seen in action once itself. It is initially it is having a mycelial formation. Then it sets to form brush heap appearance as that of actually agar. Alginate is made dust free by adding glycol. Very important. So, impression material which have high incidence of air porosity. We know, of course, we have already seen an alginate impression, right? Air porosities. So, some other not much asked question, still asked question. Polysulfide, you have to know these answers. First, dental elastomer, vulcanizing impression material, and mercaptan impression material. And very important point, they have actually lead dioxide polymer. That is why they have actually a brown color. Water is a byproduct in that. And you have to study some of the setting time. It has a messy problem because it is having that brown color, hydrophobic nature, all that important property. Again, condensation silicon you have to study. It is having good color and good order when compared to the polysulfide. Again, addition silicon, it is also known as polyvinyl silicon. It have actually some shrinkage, etc. Polyether also. These are actually not much asked, but still you have to know. So next going to, I know this is actually much into your mind, but make flashcards. This will be very easy, and go to YouTube. We can actually rewatch this, making them very easy. So gypsum product, so simple. In nature, we get it as CaSO4.2H2O. Some water is there. So what we heat it, we remove 1.5 water, that forms the gypsum product. So simple. AD specification 25, we have 5 types. Impression plaster, model plaster. Type 3 is very important, is also called as class 1. So never get confused. Sometimes the question might be, which is the class 1 stone? So you will think like, okay, it is a type 1 gypsum product. No, that is type 1, type 2, type 3. Class 1 starts from, you can see here, it is type 3. Class 1, then class 2, then class 3. Hope you understood. Okay. And class 2 is also called as densite. And it is the last one is high expansion, high strength material. Then you have to know hemihydrates and alpha hemihydrate and beta hemihydrate. So we actually do heating of this calcium sulfate, right? Heating is called as calcination procedure. So we used to make food, right? It is under pressure we cook some food, and we do that in open air. Similarly, when we cook or when we actually calcinate dental material in, I mean, dental plasters, dental stone in a closed chamber with high pressure, it is called as alpha hemihydrate. When it is open, it is dry calcination. Understood? This is the difference that comes for plaster of Paris. That is the difference that you have to keep in mind. And very important, when we keep that in pressure, it will have very dense and prismatic structures. While in the case of beta hemihydrate, since it is open, it is irregularly shaped. That is how we have to keep in mind. Very good pressure, it is very regular. When it is under like irregular shape, it is under open air. And beta hydrate actually absorb more amount of water because it have irregular crystal. That is very important question. Which is the hemihydrate that absorb more of water? That is beta hemihydrate because it is cooked or it is calcinated in open air. Next is like you have to know this chart. This is very important. As I told, the other names of type 1, type 2, type 3, type 4, type 5. You have to see this is very easy. Compressive strength like 800, 1,300, then 3,000, 5,000, 7,000. Like that, you have to study the water to powder ratio, setting time. And setting time is easy. Type 1 is like 4 to 5 minutes. Rest all are 12 to 15 minutes. Okay. So we know it is actually a exothermic reaction that is taking place when we know when we mix plaster, when water comes in reaction, there is large amount of heat that is being produced. Important area you have to know. What does see when we take 100 gram of plaster of Paris, we mix it with water. So they are saying only 18.6 ml of water is required. But we pour more water. More water is required for the formation of water of crystallization. See, more water is required. So study this box. For type 1 and type 2, I told only 18.6 is actually required. See, for type 1 and type 2, it requires 45 ml. For type 3, it is 30 ml. For type 4, it is 20 ml. Keep that in mind. The remaining water is called as the wet strength or green strength. Keep that in mind. The water that is remaining than the actual required water, that is called as the wet strength. Hope you understood. You know how much water is required for setting? 18.6. Excess water is called as what? Green strength or wet strength. That is the water that is required for crystallization. That is why for type 1 and type 2 we give 45 ml of water, but we require only 80.5 for the mixing. So the question is, water of reaction needed for the complete reaction of calcium sulfate. That is of course 18.6 ml, right? The product which is obtained by calcinating gypsum under pressure. So we know we have studied alpha and beta. Alpha is under pressure. It is alpha hemihydrate. Beta hemihydrate calcination, which is true in presence of air and absence of air. We have hemihydrate is open. That is why in presence of air. And what is the problem with beta hydrate? That is why it make irregular. Large amount of water is required. So type 3, you have to study that chart. Okay. Green strength refer to what? It is the amount of water or the wet strength. It is otherwise called as a wet strength. Hardness of stone surface is affected by hydrocolloid impression material. So another important thing that you have to know in this is the accelerators and retarders. Very easy. Accelerators and retarders are those which actually control the setting reaction. Potassium sulfate, K2SO4 and NaCl accelerate the reaction. When we add small amount of actually powdered gypsum to hemihydrate, it accelerates the reaction. That is called as terra alba. You have to keep that in mind. So you can memorize like A, B, C. A for accelerate acetate, B for borate, and C for citrate. Others like gum, etc. are actually the retarders. So accelerators were what all? Terra alba. Small amount of gypsum is actually added. K2SO4 and NaCl. So retarders are those actually they inhibit the growth of the material. The function of 2% of potassium sulfate, we have already studied there. It actually regulates the setting time, right? So we have already studied hardness testers. Like here we have to study how to test whether the plaster of Paris is set or not. There is initial evaluation and final evaluation. For initial evaluation, we will check whether there's gloss. The gloss we mix, it have a very good surface. Loss of gloss is there. Initial Gilmore test, that is very important. Initial Gilmore test is used for initial set of PPT. Final set is checked with Wican's needle and final Gilmore needle. Please keep. Some other question might be, Wican needle is used for which test? It is used for the final set of plaster of Paris. Now setting, as I told, this is again very important flashcard that you have to make. Setting expansion factor causing increasing setting expansion, less water powder ratio, allowing setting under water, increased rate of spatulation. More the spatulation means there will be increased expansion. Alpha hemihydrate, more the expansion. Smaller particles, more expansion. So decrease the expansion, water powder ratio, just the opposite. So this is very important flashcard. Please keep that in mind. So thank you. Hope you understood. We had about actually one and a half hour class. So hope you understood all these things. This is very important topic. So we'll have discussions from tomorrow. Start reading your synopsis. Any doubt, please come in our group and ask personally or in group. We'll have discussions. You'll have 2 to 3 days for the your studying purpose, and we'll go for the test and further we'll discuss the next topics. So by these 2 days, I hope you all understood all these things, right? Please go through the synopsis, see this video again in YouTube, Have a thorough knowledge, make notes. That is very important. Today you'll understand everything. Tomorrow you'll forget this. So please go. Good night. Tomorrow, get up earlier, read. Thank you.